people, and welcome. In today's video we are talking about writing equations of exponential functions. Now I'm going to go ahead and shift up. This is going to be a part 2 video. In part 1 we talked about how to graph exponential functions using the reference points formulas. Now we're going to be using those formulas to write the equation of a given curve, of a given exponential function. So when we do that, there are a little bit of some steps for you to do. I promise you they're not too bad, but let's go ahead and do that. Now the steps that I'm going to tell you how to do, we're going to write them down as we're doing them. So let's start with an example. So here is our first line. Now I do want to point out that for this graph, they typically don't give you the points. For example, here's a different one. And for this one, you can see that you have a curve. So this is a different function. But you have a curve, but they don't actually tell you what the pretty points are. So what you're going to have to do is identify your two pretty points. You want the closest 2 points together that are closest to the asymptote. So for this one here, again, this is not the example we're doing, but for this one here, I see a pretty point here, and I see a pretty point here, and I see a pretty point here. So you want the pretty point that's closest to the curve, closest to the asymptote. Now on this one here, this could be your y-intercept, and then this could be your first reference point. Keep that in mind. But for something like this that we're doing, I have identified these 2 points as our first 2 reference points. So let's go back here. I have also identified your asymptote. So if you go back here to the original examples off of the website, you'll notice that the asymptote is not actually shown. So the asymptote is an imaginary line that you shall not touch or cross. So because it is imaginary, it's not actually visible to us. We can't see where the asymptote is, but we don't actually see the line drawn. Here I went ahead and I drew a line, so it's just going to be a little bit easier for us to identify where our asymptote is. All right. Step number 1 is always to identify if you have an increasing or a decreasing function. So let's write that down. Step 1, increasing or decreasing. And the reason we need to know if it's increasing or decreasing first is because we need to know if we need to use this formula for our secondary reference point or this formula for our secondary reference point. Are we getting larger? Or are we getting smaller with our curve? In this case, for step number 1, we are going up, up, up and away. So that means we are increasing. So that means for step number 2, we're going to go back and finish the steps, writing out the steps a little bit later. But for step number 2, that means you're going to write out all of your formulas. So you have your h comma a plus k, since we are increasing, your 1 plus h comma ab plus k, and your third one is y equals k for your asymptote. And again, we are using this one here, your 1 plus h, because this is an increasing function. We are going up, 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 and away. For your third step, you're going to identify, start plugging stuff in. So we know your k value. Actually, let's do this before we do our step 3. Let's, for step 3, write out our formula. So f of x is equal to a times b to the x minus h power plus k. Ooh, plus k. I wrote 2 instead, but that should be a plus k. I don't know why I wrote 2. That's not even the correct number. So that's going to be our step 3. Step 4, let's go bring down step 4 here. Step 4, let's now start identifying things that we know. First of all, I know what my k value is. I know my asymptote is at 1. So that means k is 1. From that, I need to know what my first point is. My first point is 2, 4. Oh, that's actually my second point. So 2, 7 is my second point. My first point is, let me rewrite that, you guys, because that's 2, 7. My first point is 1, 4. So what you're going to do after you identify your asymptote, you're going to take your first reference point, the point closest to the curve. That's going to be your first reference point. You can also think of it this way. If you have an h and you have an h plus 1, So you're going to set the 1 with the h. If you add 1 more, that's going to be 2. So your h comma a plus k is now equal to 1 comma 4. This is where it's kind of cool and magic starts to happen. So notice how I have an h in front, and notice how I have a 1 in front. That means that h is 1. And now let's do the same thing for the other one. I have an a plus k and 4. So that means that a plus k is 4. However, we don't really want a plus k. We just want a, and we just want k. So what you're going to notice is you already know what k is. K is equal to 1. We have identified what k is because we know what our asymptote is. So I'm going to say I know that k is 1. So that means if I subtract 1 from both sides, a is equal to 3. And that's what I mean by magic starts to happen. Now we know that k is equal to 1, we know that h is equal to 1, and we know that a is equal to 3. So let's write out our formula, and I'm going to write it here. So this is going to be step 6. So now I have my f of x is equal to a is 3. We still don't know what b is. We know that h is, what is h? What did I say? H was 1. So we're doing the opposite. In this case, it's minus 1. And we're doing our plus k. And plus k is 1 as well. Okay, so we're pretty much done at this point. The only thing we need to figure out is our b value. Now, there are two things that may happen. The first thing, and we're doing a happy dance when this happens, the first thing is sometimes they will give you the b. They'll say, find this equation when b is equal to blank. Sometimes they will not give you that value, and instead what they're going to do is assume that you know how to figure it out. So when you have a b value like this left over, and I'm actually going to help you out here just a little bit, they're going to give you more points. So like if I'm looking at the example here, you have lots and lots of other pretty points. So you want to use one of your pretty points that is on the curve that you have not already used to find what the b value is. In this case, the third pretty point is at 3, 13. And that's going to be your x and y, just like we did previously to find our other values. Here's your x, here's your y, and you're going to solve. And I'm going to see if I can use a pencil here. Not sure if it's going to show up, so I might change, just because I want to write in a smaller print. So we have y is equal to 13. B, we don't know what this is. X is 3, and we know that k is 1 and h is minus 1. So that means I have 13 is equal to 3 to the b squared plus 1. I'm going to subtract 1 both sides. I'm trying to get b squared by itself, so I have 12 is equal to 3 times b squared. I'm going to divide by 3. So I have 4 is equal to b squared. I'm going to take the square root both sides. So b is equal to 4. Now keep in mind, whenever you take the square root of both sides, you do have a plus or minus, not 4, 2. You do have a plus or minus on that value. So technically this is plus or minus 2. However, we can't have a negative here because that means we would have a transformation, right? We would have a value of -1 times our b, and we would have a reflection across the y-axis. So we don't have that. So it's going to be a positive 2 because we are increasing. Also, we can't have a -2 because this would be a decreasing, right? Decreasing. Decreasing because -2 is smaller than 1. So anytime you have a b value smaller than 1, you have a decreasing function. But we can physically see that this is going up, up, up. So now we have b is 2. So for our final answer, let me write it up here. We have f of x is equal to 3 times 2 to the x minus 1 power plus 1. and that is our equation for the given function. I'm going to zoom out just a little bit, for you guys to see a little bit more of what happened. And we're going to write in our steps. So step number 1, we determined if it was increasing or decreasing. Step number 2 is writing out the formulas for the points. Step number 3 is write out the actual formula for the equation. Step number 4 is identify your asymptote. And that's always going to be y equals your k value. Step 5, you're going to use the first reference point to find what your h comma a plus k is and find what your a, b, so I'm writing here, what I'm doing, you guys, is I'm writing out the formula, the steps for you guys. So first step is write out the formula for the points. Oh, sorry, that was second. Third step is formula for the equation. You're writing out the formula for the equation. Fourth step is we found the asymptote. The fifth step, use the reference points and formulas to solve for h, comma, for h, let's not do comma, h and a. Step number 6 is use a third point to plug in for x and y and solve for b. And I'm going to write look out for positive versus negative b value. Again, if it's greater than 1, it's increasing. If it's less than 1, it's decreasing. All right, let's use those steps in our secondary example to write the equation. Step number 1 is we need to determine if this is increasing or decreasing. In this case, it is decreasing. So we know that our b value is going to be less than 1. We also know that we are using our secondary equations. So what do we have here? We have, and you know what, you guys, I realized that for our third point, we could have used the 2, 7 for our secondary point because we didn't use